Hi, everyone. Thank you for attending this session and for having me speak at Azure Cosmos DB Conf. My name is Nick Greenfield. I'm a senior product manager at Microsoft, and I specifically focus on the Dapr project and its integration with our various Azure services like Azure Cosmos DB. This session is titled Exploring Dapr's Integration with Azure Cosmos DB. But before we dive into that integration and what it looks like and how you can use Dapr with Azure Cosmos DB, we'll spend a couple of minutes explaining what Dapr is and how it's used by developers. So Dapr stands for Distributed Application Runtime, and at its core, it's a runtime that offers developers a set of incrementally adoptable APIs and various capabilities that simplify implementation of microservice patterns and best practices. Dapr is an open source project, and it's part of the CNCF, which stands for Cloud Native Computing Foundation, as an incubating project. It's actually up for graduation as we speak. So it sits alongside a lot of other prestigious projects like CADA, gRPC, NATS. So Dapr is completely open source and it has a really strong community backing it. So this is a high-level overview of Dapr and the capabilities that it provides and how and where you can use it. So the Dapr APIs are categorized into what we refer to as microservice building blocks. That's this middle row here. These building blocks are capabilities or certain functionality that is often present in a distributed microservice system. So as I mentioned earlier, each one of these APIs is incrementally adoptable. So you can pick and choose them as the need arises. And we do have some users that just use one API or a combination of the APIs together. If you go to this top row, Dapr works with any language or framework as long as the applications are leveraging HTTP and gRPC. That said, there are SDKs that Dapr provides, which makes using these APIs a lot easier, and they follow the conventions of the programming languages that they're written in. In this bottom row, Dapr can be run anywhere. It's platform agnostic. We primarily see users using Dapr in Kubernetes environments or serverless paths like Azure Container Apps, but there's also users that are using Dapr on just VMs and orchestrating Dapr themselves. So moving into the architecture of Dapr and breaking down how it works. So Dapr leverages the sidecar pattern as shown in this slide here. And in its simplest form, every microservice that's deployed to an environment is accompanied by the Dapr sidecar. And this is how an application is able to leverage all the different Dapr APIs that are available. So as you can see, these are some calls using Dapr APIs. Invoke, which is a asynchronous request response API, state management, how you manage state within your application, PubSub, asynchronous message passing, and then secrets, being able to retrieve secrets that are stored in your application. So as you can see, with these APIs, the format of the calls are always the same. So why is this nice? Well, when you use Dapr, developers only need to learn one set of API calls to leverage every different capability that Dapr provides. So this image here illustrates how Dapr does all the heavy lifting for how an application can integrate with some technology service, whether that's a state store or a message broker or secret store, basically everything that you see on this slide here. So Dapr is able to handle the plumbing for how an application can connect and communicate with one of these technologies, which ensures that an application code can remain portable from the technology that it integrates with. And as you can see in this diagram, I've highlighted boxes around where Azure Cosmos DB fits into the Dapr APIs. So Azure Cosmos DB can be leveraged in the state management API as well as the bindings API in Dapr. The state management API allows you to save and retrieve key value pairs into a state store like Azure Cosmos DB. And this provides a way of building stateful, long-running applications in your code. You could think of that as an example would be like a shopping cart, where you can save items into a cart, or saving a game's in-session memory state. So Dapr can also leverage Azure Cosmos DB through the bindings API. And the bindings API supports an input and an output direction. An input allows you to trigger your application based on an event from an external system like Azure Cosmos DB. And the output binding allows you to invoke an external system. So Azure Cosmos DB is one of 115 different components that the Dapr project supports today. And so speaking of components, Azure Dapr components are authored in Go, as the whole project is actually. The Dapr project is completely open source, written in Go. And every component can be found in the components contrib repository in GitHub. So on my screen here, we're looking at the Azure Cosmos DB component for the state management API. And this will have the whole implementation for how Dapper can interface with Azure Cosmos DB. And one crucial part of this implementation that you'll see that I've highlighted is how the Dapper project relies on the Azure SDK for Go for Azure Cosmos DB. That's how it is able to connect and communicate with an Azure DB service. So this is an end-to-end if you were using Azure Cosmos DB with the Dapper State Management API for saving and retrieving state. So what we see here is I have a microservice that I've called my application, my app. It's accompanied by a Dapper sidecar. And this sidecar at runtime will load all of the component configurations that I've provided. So if my application was going to communicate with Azure Cosmos DB via a component, it would load that state store component as part of that definition. Once that's loaded, I can then start making API calls to Dapper to save and to persist and retrieve state to my Azure Cosmos DB service. So here you can see the local host 3500 is the default address that Dapper runs on. I'm invoking the version 1 of that state management API, and I'm persisting state to my state store, which in this case is my Azure Cosmos DB state store. And I've set a key value of Jedi, and Skywalker is the value, planet and Tatooine is the object here. And so what that looks like in Azure Cosmos DB is I have a key of my app. So Dapper by default will prefix all of the data going into the state store with the name of the app it's coming in. That's so that if multiple applications were leveraging the same state store component, you know exactly where that data is coming from. And so it has the key of Jedi and the value of Skywalker, and same for planet and Tatooine. Then I can make a GET request. So very similar structure, state, the name of my state store component, and then the key that I'm trying to retrieve from that state store, which return that object of Tatooine. Okay, so now I want to demonstrate Dapper's portability. And so what I want to show is how the inner loop with Dapper. And so I'll be using the state management API locally. And I want to show that, in that type of environment, I'm not going to be running Azure Cosmos DB. I'm actually going to be using something a little bit lighter weight. Dapper provides convenience tools when you install it. And so what it will do is it will spin up like a Redis container on my machine and give me a state store for that local development that will be using Redis, right? And so this is a really simple example of me using a C# SDK in Dapper, and then I'm able to persist state calling a save state method on that client. And so the 3 parameters that you see here are the component where I'm saving my state to. And so in this case, it's state store, which matches the definition of my component state store, the key of that I'm saving, and then the actual payload, the order here as the value. And so this will save state to my locally running Redis container on my machine via Dapper State Management API. Now, let's say I wanted to take the same exact solution and deploy it into Azure, but swap out the Redis for something more appropriate. So if I'm going to deploy this into, let's say, AKS, I probably want to use something like Azure Cosmos DB as my backing state store, no longer wanting to use Redis. Well, I can do that. I can achieve that without any code changes. It's a simple configuration change. And so what I'll do is I will just swap out that component configuration for my Azure Cosmos DB configuration. And so here you can see the name still matches the component state store, except it's no longer Redis. It's state.azure.cosmos DB. And then I have all the connection information for how I can connect to that Azure Cosmos DB. So this is what I'm going to show. And I apologize, my terminal, brand new computer, so I'm lacking all the fancy colors. I haven't bootstrapped it yet. So bear with me in that regard. So what I'm going to do here is I'm going to run, I'll just show you that I have Redis running on my machine as a container. Again, when you install Dapper, it spins up some convenience tools. So it's going to install Redis, and it's going to give me a default state store component. And again, just to show what that looks like, here's that state store component, right? It's Redis, and then how it connects to my locally running Redis. And so what I'll do is I'll run Dapper with my application. And this is just going to, in a loop, persist and retrieve state to that locally running Redis instance. So it's starting up. It's my Dapper logs. Great, so it's working. So in a loop, it's saving order, getting order. In this case, it's deleting order. 1, 2, it's going to keep doing that in a loop. Now, if I Control-C out of that, we'll go back to my code here. And I'll switch to this. What I'm going to do is I have that same exact code. I've built it into an image, I pushed it into my container registry. And instead, I'm going to deploy it into my AKS cluster. And when I do that, I'm going to deploy it with a new component configuration, no longer using Redis. It's going to be using my Azure Cosmos DB definition. And so that's what we'll do. So let's go here. Let's switch over to this. And so I'm just going to do a simple kubectl apply, and I'm going to deploy that one service with that component. So here you can see deploying my order processor service with that backend state store. So now I do kubectl get pods. You can see I have 2 of 2 running. So my service itself with the container, 2 containers. So I have my service running with the Dapr D sidecar. And if I look at the logs for that, you can see it's persisting state and retrieving state from my Azure Cosmos DB state store. Same exact code, didn't have to change anything, just a simple configuration change. And that's all I have for you. Thanks for joining today. If you want to learn more about Dapr and how it works with Azure Cosmos DB, you can go to dapr.io. There's documentation with a lot of quick starts for getting started with Dapr, and you can jump into exactly what I showed here today.